Hi guys, in this video we go into the details of pandas. This is the table of contents of this video. Pandas series, pandas data frame, row and column sum, indexing and slicing, summary data frame, subset, change column name and order, handling missing values, multi-indexing, group by, concatenate, append, and merge. Let's start by importing numpy as np and pandas as pd. Okay, pandas series. Let's build a list. Now, to build a Pandas series, we pass this list to pd.series. Let's check. And as we can see, this is a Pandas series. You can also check the data type. Now, indexing and slicing, even though we will discuss this in details later. You should already be familiar with this notation. We are selecting from index 0 included to index 3 excluded. So these are the values 1, 3, and 4. Now we are selecting from index 0 included to index 6 excluded every two. We can check the index. So the index starts at 0, stop at the 6 not included, and the step is 1. Let's check it. You can see start at 0, end at 6 not included, and the step is 1. 0, 1, 2, 3, 4, and 5. Okay, but let's say that the index should be years. So I want to modify the index. When we build the series, we can use the argument index. In this case, index equal, this is a function from NumPy, so np.arange from 2010 to 2016 excluded. So when we do like this, now we have modified the index. And we can select the value by using the index. So as 2014, this returns the value 11. We can also build a series from a dictionary. So let's say that we have a sales value. So we have sales 2018 100, 2019 120, 2020 90, 2021 75. As you can see, this is a dictionary. We just pass the dictionary to the series, to pd.series. And here, it's our series. And now it's very easy to plot directly with pandas. So sales.plot, we have a line plot. Now let's move to data frame. Okay, so we have data X and Y, and we want to put this data together as two columns. If we pass X and Y to pd.dataframe, as in this first example, what happens is that Y takes the place of the index. So as you can see, the value for Y placed at the index. Naturally, this is not what we want. We want data frame with two columns. So now let's pass X and Y as a list. So we're putting X and Y together as a list, and we're passing this to pd.dataframe. If we do like this, we put together but horizontally. So we have this dataset is wide. This is not what we want. We want two vertical columns. How do we do that? We use the zip function. So pd.dataframe zip X and Y. And now we have a data frame with two columns. Let's make another example. Here we have product 1 and product 2, and let's build this data frame. Now, clearly, we have the column names 0 and 1 that are not really appropriate. So what we can do is that when we build the data frame, we can pass the names in columns. Columns equal product 1 and product 2. And as you can see, now we have product 1, product 2. It may happen that also the row index can be modified. So here we select index equal. And let's say that these are countries. So Japan, France, Italy, USA, and Germany. As you see now, our data frame, we have product 1, product 2 as column names, but also now the index, we have the name of these countries. And we can make also a plot. In this case, we can go for a bar plot, so df.plot.bar. This is the outcome. Row and column sum. Okay, let's check again the dataset. Now what we want to do is to sum product 1 plus product 2. How can we do that? We select the column product 1 plus the column product 2. Here, Japan, 225, we sum 100 and 125, and so on. Clearly, if we have several columns, this process is quite tedious. So what we can do, and what we do when we want to make the sum, we use the sum function. So here I'm generating a new column in the data set, df. Okay, and this new column is the sum of axis equal 1. So we're summing values in each row. So this sum, this value plus this value, and so on. Let's run here. And as you can see, we get the same result of df product 1 plus df product 2. Now, let's say that we want to add also a row with the total for the product 1, product 2, and from total. In this case, we can use this line of code here, df.append, and append what? The result of this line of code here. So what we are doing, we are summing, and note that we have nothing here because the default value here is taking 0. Then we are sending the value that we sum to a frame, and then we are transposing the result. Finally here, we rename the index that by default is 0 equal to total, and we are appending this value to this df, this dataset here. Let's run this, and then we break down. As you can see now, we have the total for the product 1, product 2, and the total column. Let's break it down. Here, df ilog 05 here. We will return to this ilog in a moment, but what we are doing, basically, we are selecting this dataset here because we don't want the total, because we want to reproduce this result step by step. So with this command here, we are just taking this dataset here. Okay, let me show you. X is equal 0 because now we are summing the values in each column here. And as you can see, we are returning these values here. And if we don't use axis equals 0, you can see we get the same value. Now, the next step was to underscore frame. Let me show you. We are just framing this result. Now we have an issue because the last step is basically to append these results to the previous dataset, but the dimensions now are different. For this reason, we are transposing these results. Now we have this basically this dataset with the right dimension, with the right column names. The last step that we did was to rename this index 0 as total. Let me show you. this was rename index 0 as total, and then we appended this to df.append. This is what we did. We will return to append later in this video. Okay, let's continue indexing and slicing. Okay, let's check again our dataset. If we want to select only product 1, the column product 1, we can do like this or like this. But the best way to work with Panda is with loc and iloc. Loc stands for location. So here I want to select the values where the location is Italy. So when we run this, we get product 1, product 2, and total. And these are the values in these columns. We can check it. We select the value for Italy. Product 1 is 110, product 2 110, and the total 220. Now, if we want only one column, so the location where Italy and product 1 basically are, so here we get just 120, 110, this one. We can make multiple selection. In this case, we want Italy and Germany. We're passing Italy and Germany as a list. And that's it. Value for Italy and Germany for product 1. Check it. Product 1, Italy and Germany. So what's that iloc? Iloc stands for index location. So instead of using the name, we are using the index. So Italy is located at the index 2 and product 1 at index 0. Let's check it. So pandas Python start indexing from 0. So upon 0, 1, and 2 Italy. This is 0, 1, 2. And this is what we are doing. Basically, we are replicating this result here, Italy product 1. If we want to replicate this Italy Germany product 1, now where is Germany? Italy is 2, USA 3, Germany is 4. So 2, 4, and we replicated this result here. Okay, summary data frame. With the head function, we visualize the first 5 rows by default. Okay, we have 0, 1, 2, 3, and 4. There are in total 5 rows. We can use the info to get some info about the data frame. So here we have the class, the pandas data frame, index 6 entries from Japan to total. Now total we cannot visualize here because this is the result of the head function. And then here we have total 3 columns, product 1, product 2, and total, non-null content, and the data type. If we want the summary statistics, we can use describe. Here we have a bunch of summary statistics. Okay, and we can also summarize visually a data set by using the style background underscore gradient, where basically we are mapping the value to colors. We are setting the colors based on the value in the data set. Example like this, we can see here in this column, the largest value is 120, and this one is 180. Change with the axis. Okay, so this is just to visually see the data in our data set. Now subset. Let's check again the data frame. So we can use the iloc. For example, I want to remove the total. For the row, for the column. I'm using the iLock. Now we don't have anymore the total for the row and for the column. Now, for example, let's subset here. We're using a logical input. So if product 1 is greater than 100. Basically, this comma in this semicolon here, where basically the first, this value here is referring to the row index. Comma, with this one, we're saying we want all the columns. The result needs to be returned for all the columns. Let's run. And as you can see, we have only France, Italy, and Germany, product 1 and product 2, because product 1 is greater than 100 only for France, Italy, and Germany. We want only to return product 1, the column product 1, we just select the column product 1. Change column name and order. Check again the data frame. Let's add a new column. We call it XYZ. And now I want to rename product 1 and product 2 as ABC, PQR respectively. So here, df.rename columns equal brace product 1 column ABC, comma, product 2 column PQR. We can change the order of these columns by selecting the index. So we use iLock. Here, we're saying change for all the rows. Okay. What we did here, we moved the XYZ that is at the index 2 in front of 0 and 1. So we move this column at the beginning. Note that we didn't modify the data frame like this, okay? We can also reverse here. We're just using -1 at the end. Be familiar with this notation from past videos. Okay, and we can also use the names, the columns. Now, handling missing values. Let's place a missing value for France and product XYZ. So here, location France XYZ, we set not a number, this is none from NumPy, okay? And as you can see here, we have not a number here. If we do describe, this is a difference between, in this case, the summary function in R and this describe, because the summary function in R tell you explicitly that the data set, the column, is a missing value. We describe, we can deduce it, for example, from the count, but let's do more appropriately. So what do we do here? We use the isNav function. When we do like this, we check which value is a missing value. And as you can see, we have all false but one that is true, where France and XYZ. If we add the sum here, this automatically returns how many missing values we have in the columns. For ABC 0, for PQR 0, for XYZ we have just one missing value. Okay, this is how you can count the missing values. Now, how to deal with missing values. Here I'm just showing you the technique. Then how you will deal with the missing value in your own dataset depends on the data that you collect and also on the how do you say, on how you deal in your specific field. Okay, so let's see, for example, how to drop the missing value. If we use df.dropNav, here we are removing all the row all the rows with the missing values. As you can see, we don't have France anymore. Where is France? Here. As you can see, we removed all France. This means that we removed also the value for ABC and PQR, where we have values. So we can decide that we want to keep ABC and PQR. So what we can do, again, not that we didn't make any modification here. So what we can do is that we select column, axis equal columns. So when we do like this, what we do? We are dropping the column with the missing value. And again, here we are losing information. For example, we don't have anymore 100 for Japan, 110 for Italy. Again, this depends on what you want to do. And again, we are not saving this in this result, okay? What we can do, we can fill the missing value. So in this case, we use fill now. Let's fill with 0. And we can use the method of forward fill or back fill. So forward fill, what we do, we are passing the previous value to the value where the missing value is located. So when we do here, df.fillNow method FFILL, so forward fill, basically we are passing 100 to France in this case. Again, this perhaps this is not the best example with this data frame, but let's continue like this. Again, just for the technique, backward fill. So what does that mean? That we take the value, the following value, and we're passing where the missing value is located. In this sense, in this case, we're passing 110 from Italy, where the missing value is located, and that it's in where France XY. And as you can see now, we have this value here. We can decide to fill with the mean. So here we are filling with the mean of the XYZ column. Now let's make this modification. So now I am modifying the dataset with the mean. Okay. Multi-indexing. Set the year data for 2000 and 2020. Countries represent the data, the dataset ID, while years represent the year index. So I generate this object here, index Japan 2000, Japan 2020, France 2000, France 2020, and so on. Let's say that we have these GDP values for these countries for those years. Now let's build a data frame. Now we pass GDP, the data. We set the column's name as a GDP, and now we are passing a multi-index. One index for the country and one index for the year. And as you can see, we have this index for the country, this one for the year. So this is Japan 2000, 2020, and the value for the GDP, and so on. Let's say that we want the values for the GDP into different columns. We can use unstack. So let's save this operation in df_year. And as you can see, we don't have anymore the year index, but we have two columns, GDP for year 2000 and 2020. If from this kind of data set we want to set the multiple index, we can use stack. And as you can see, we are back to the multiple index with France, this country, and the year. And we can actually pass these names. So we use df index dot names, and let's pick up country and year. As you can see, we have country and year. We can also add another index. For example, here I'm adding an index for the region. So Japan, East Asia, France, Italy, and Germany, Europe, and USA, North America. And again, we can pass the index names. Now we can see some group by operation. So we have this dataset here. We want to group by level equal country and take the mean. So basically, this is the value. This is, we have only one value here, this GDP value. And we are taking the mean by country. So this is the mean for France, for Germany, Italy, Japan, and the USA between year 2000 and 2020. For example, let's check here. Germany, 2000, 2000, 3000, 2020, 4000, and the mean is 3500. Let's take the mean region. And as you can see here, the value for East Asia and North America here is the same for Japan and USA because we have just one East Asia and one North America in all the data frame. But for Europe here, this is the mean for the region for those years. You can also make the group by operation multiple values here for multiple references, so region and year. So concatenate. Let's generate a new data set. This one. Now what I want to do, I want to append, I want to add the data set for the information for UK and China. So let's build a data frame. So we have this one, UK and China. And now I want to add this, the previous one. We can use concat. So pd concat df1 and df2. And we added this, or we appended these values. Let me show a different example. So we built two data frame A, B, and XY. And now let's concatenate this A, B, and XY. Not something now. We have a repetition of the index. Perhaps we don't want this. So how we can remove this by ignore underscore index equal true. When we do like this, now we have the index from 0 to 5. Another option is to actually add the multi-index. So we are adding keys. In this case, I'm using the name of the two dataset. So when we do like this, again, we have 0, 1, 2, 0, 1, 2, but now we have A, B, and XY. We concatenate, we append it by row that is the default, but we can also do column bind. In this case, we have to specify the axis equal 1. You can see this was the first one, A, B, and this XY dataset. Okay, and naturally, the dimension is to be suitable for this kind of operation. Okay, we can use the append. This is what we used earlier. Again, here we appended UK and China. Okay, last section, merge. This is the F1. Let's reset the index. So we use reset underscore index in place equal true basically to save this operation. So basically what we did, we don't have anymore the index as a country, but we have one column as country with the information. Okay, now let's build a new data frame with, let's say, data for population. And now we have this information for country GDP and for country population, right? And we want to put all together. So we use the merge function. So pd.merge df1 population. France is the value of GDP and its population. Let's add a new column population. So let's add also the capital. Let's merge again. As you can see now, we have a country, GDP, population. Okay, in this example here, the two data set, the two data frame that we are using have the same information for the country, but it may happen that the two data frame have different information. So let's generate this population too by selecting only France, Germany, and Italy. So now we want to match DF1 and population 2. So when we do this kind of operation, as you can see, we don't have anymore the data for Japan and USA because by default we are implementing an inner join. If we want to keep the information for USA and Japan, we can do in different way. For example, we can specify how equal outer. And as you can see now, we have the information for Japan, USA, basically the GDP, because population capital, we don't have this information in population 2. Yeah, this is population 2, and as you can see, we don't have the information for Japan, USA. So naturally, when we do this merge now, these this cell are filled with missing values. Okay, another way to do this, to do the merge, is to specify the left or the right input. In this case, left input is df1. We do like this. Again, we replicated the same result. But if we specify right input, as you can see now, we don't have any more USA and Japan because they are not in the population 2, that is the right input. Okay, another situation is where the two dataset, the column that we want to use for the merge, for the index, has a different name. So let's rename the column name country as a state. We save this in population 3. So now DF1 and population 3, they don't have the same column. So we have to tell Pandas which column has to use for the merge. And this is what we are doing now. Pd.merge df1 population 3 left on country. So use column country for the left input for df1 and use column state for the right input population 3. Okay. Now here, note that we have a repetition of information because basically country, state, they contain the same information. So what we can do is drop the column. So here, this is the same operation as before, but we are adding dot drop state comma axis equal 1. So drop the column state, what we are doing. As you can see, we don't have state anymore. At the beginning, we reset the index, but actually we can also merge by using the index. So let me show here. We are setting again the index. And here, pd.match df1i, population 3i, left underscore index equal true, and right on state. Okay? That's it. We merge again these two. So that's all for this video. I hope it is useful, and see you in the next video.